Good evening, everyone, and welcome to today's Morocco HPC webinar. I am really happy to be hosting another session where we explore different technologies that are actually shaping the future of computing across Morocco, Africa, and beyond. For those of you who don't know us, at Morocco HPC, our goal is basically to create a space where researchers, engineers, and also just enthusiasts can actually learn, exchange ideas, and also build a stronger HPC community. And today's topic is one that connects two main worlds that many of us work in, basically high performance computing and cloud computing. So our session is titled HPC Meets Cloud, Designs, Costs, and Real-World Workloads. And I'm really excited to introduce our speaker, Aziz Imgharen. So Aziz is a platform engineer who helps companies design and operate smart, scalable, and also cost-effective platforms across cloud, data, and AI. And he also brings a very practical perspective, one that is really grounded in real architectures, real constraints, and also real workloads. And he's also the host of E After Work, which is a weekly live show where he brings experts to discuss Gen AI, platform engineering, modern infrastructures without what he calls buzzwords. And today, Aziz will walk us through what happens when HPC and cloud actually intersect in production environments, which means how organizations actually extend workloads into the cloud and what cost models look like and how to design systems that balance performance, scalability, and also efficiency. So thank you for being here, and please feel free to drop your questions in the chat. We will make sure to take them during the Q&A after the session. Aziz, thank you very much for accepting our invitation and for being here today, and the floor is yours.
Oh, thank you very much, Safai. That was a great introduction. And hi everyone, hi to the community of HPC. First of all, congratulations on organizing this event. I know it's very hard to organize such event and to get people to come here and talk about such a topic, which is HPC, which is hard to to touch upon. And I've been watching some previous videos and I like them. I've watched the video we talked about with Sufyan about the on-premise setup using their product, which is Sambanova. I also watched another topic, which is the one of the environmental impact of HPC, and the topics that you're touching upon are very interesting. And for today, it's another topic, another interesting one where we are going to talk about the HPC and if it's something that is feasible to do on cloud, and basically should we go and do it on the cloud. So before doing so, a few words about me. As you said a lot of things. I'm just going to basically re-say them. I'm a platform engineer, meaning that my daily tasks are basically building platforms and trying to maintain them. And those platforms may vary depending on the specific need, on the business need. I've worked with multiple clients. They range from the private sector, banks like BNP, to public ones, to French government. As I said, it's basically a task where your main task is to build a platform, either there is data platform or an application, and you need to support it and to maintain it by observing it and keeping it alive. As you said, I also do podcasting on the side. I host experts basically on the platform engineering field, but also other fields. And we talk about different subjects. So if you're interested in this, you can check my LinkedIn or YouTube, and then you will see those lives. I'm certified on Cloud AWS, and then a couple of other platforms that have to do with the platform engineering, namely Elastic, Splunk, and the other vendors of the platform engineering solutions. For my background, I basically come from a technical background. I did class prépa, then engineering school in Morocco, and then in France, and then a couple of masters in data science and data engineering. So enough about me, and let's tackle the topic here. But before doing so, I want to set the ground for what we are talking about. So the first thing that we need to know is the definition of the cloud. So what is the cloud and how do we define it? The classical thing, or the way to understand this, is when you're trying to build your platform, your IT platform, either that is HPC or any platform out there, what you need something to run it on. You need some hardware. So if you are buying this hardware and you are setting it up locally, we are talking about an approach that we call on-premise. What you're doing basically is you're getting the hardware, and then you're getting the network, and you're paying somebody to come in locally and install everything, and you need to maintain these things on premise. And this setup is called the on-premise solution. Now, if you subcontract this task of this whole hardware thing to someone else to do it outside of your premises, now we are talking about on cloud. So basically, the cloud solutions are just a concept of saying that you're renting the hardware and the network, and then the people who manage it somewhere else. And this is very important because this will dictate how we are going to interact with our infrastructure. And if we agree on this definition of the cloud, then we will derive from it the cloud providers. And the cloud providers are nothing other than the companies that provide us with this virtual hardware that was once in our premise, and now we are getting it and subcontracting it from these companies that we call the cloud providers. The cloud providers out there, the most famous one are the AWS or Google Cloud or Azure. And this category, the first one, which is the AWS and GCP, Microsoft Azure, we call them the hyperscalers or the big three. And we are talking here about the big three in terms of the market share that they hold. So together, they add up to more than 65% of the market share. And this is important because market share equals investment money. And they can allow themselves, or they can have the budget for innovation to create products that serve other purposes than just the simple purpose of renting hardware. And that's why for those tier one, we can talk about products that, for example, would serve for HPC, which is a very specific workload. And on the tier two, we have what we call the global providers, but that are less present on the market. We are talking about the Alibaba Cloud and Oracle Cloud, for example, and the IBM Cloud. Those are still international companies that basically have their data centers everywhere around the world, but they are small in terms of the market cap. And then we have the tier three, which are the regional specialized providers, which we can find in regions, but not globally. For example, OVH Cloud or DigitalOcean. And for the rest of the presentation, as I said, we're going to stick with tier one or hyperscalers, because as I said, those are the only ones that can provide or can allow themselves to invest in such specific workloads like HPC. For the rest of this presentation, it's going to be 4 sections, and every time we're going to have a problem and the solution. So the problem that we have on premise, and then the solution that the cloud solutions offer for us. So the first problem that we have here when dealing with the on-premise mindset is the fixed and aging clusters versus the exploding demand. And what we mean here is when you're trying to do what we call the capacity planning, meaning estimating the capacity that or your workload that you need to run on your hardware, what you're doing basically is you are doing this estimation in order to buy some hardware, and this hardware needs to get delivered to you, and you need to install it. And between the time where you do the capacity planning and the time where you get the product delivered, there's a wait time, and this time goes and gets extended. Namely, nowadays when you have a lot of competition regarding the chips market, etc. And by the time you get the product, your need or your capacity planning may have changed. So by the time you get the hardware that you are intending to run on the first capacity planning, you have a new capacity planning, and you keep delaying this, and you have like a queue of, or you have a delay on your workload. The second thing is the velocity of evolution or improvement is different between the hardware and the model. So by the time you get the hardware that you, based on your calculations, will last for 4 years or something like this, there is a new model in the market that is more efficient in another type of hardware. So you bought the hardware that you can only use on legacy models, and you cannot use on new models because they require some new features, or they are optimal on another type of features. The other thing is surprises. So when you're doing your capacity planning, basically what you're doing is you're trying to be optimal in terms of the budget that you want to have. So you are trying to get the size or the right capacity planning for the nominal usage and not the surprises or the peaks of the knowledge. So whenever you have a peak, then you will have a problem, and then you cannot run this peak, and then you will have a queue on your workload. So all those problems that are solved with the cloud. Why? Because the the cloud offers you basically all of the products that I have mentioned, or the hardware, in a virtual way, and that is available for you on a click of a button. So for example, if we talk about AWS, you can see that we have instances of compute, EC2, HPC, 6A, etc. And Azure, we have like the equivalent. And all of those products are at your disposal, and you can run them on demand, and you can get them basically instantly without you waiting for all this period of delivering. So how can you use this? You can use it with the mindset of hybrid. So for example, you can always have your capacity planning for something that you deem permanent in terms of time. So if you have something that you know that you're going to run for a couple of years, you can always get this. And then anything that is a surprise, or anything that is anything that is a surprise, or anything that is out of your initial capacity planning, you can offload it and send it to the AWS. Now we're going to go to the second set of problems. And the second set of problem is this this link between the CPU and the storage. When you're doing your capacity planning, you are basically, or generally, which is wrong, you are generally focusing on one of the components. Either there is CPU or storage or network, and you tend to forget, or you tend to not get up to date in the other technologies. So you may, for example, get the latest hardware that allow you to get the most of CPU, but then you did not optimize for your storage. And what would happen in here is you will be limited by other parameters that you did not take into consideration, like the IU, or the type of the file system that you are using, etc. If you go to cloud, if you go to those solutions, you can take advantage of the latest software, or the latest file systems. For example, here we're going with Amazon FCX for Lustre, which is the latest technology in terms of the file system, and you can couple it with the CPU that you have. And for example, here, as I said, you can use the distributed file system, etc. The third problem that we have in here is the operations that you need to do on your on-premise solutions, and this relates basically to my job as a platform engineer. So when you have a hardware, and you have you have a hardware or an on-premise data center that you need to manage, you are basically going to deal with the operation people. You need to deal with the run people that are going to run the platform, and you need to deal with the people who are going to maintain physically the setup. And this is something that you add into the equation of management. So you're not only managing the team of research or the team that is going to run the models, but you also need to manage the people who are going to maintain your hardware. And for example, if we take here a small example, the people who are going to install drivers, or the people who are going to code the schedules, etc., they are another team that you need to manage, and it will take time to manage them. It will take resource resources from you to manage them. And the solution here is to go with the cloud approach. And the cloud approach is, instead of you managing this, you need to give it to the, let's say, the cloud provider, and turn the team into a sheet of a JSON or a YAML file. So instead of you like having the instructions that you need to give the people, those instructions, you translate them into commands and YAML files. And basically what you say is, I need this hardware delivered to me. I need this hardware connected to that hardware. I need all this set up together. And I put all of this into a JSON file or a YAML file, and then I give it to something that would run it for me, like AWS Parity Cluster, or something that would translate those commands into actions that can be run on virtual hardware and provide me with the end purpose in this case, which the end purpose for me is to make calculations, to do calculations on a stored data. The fourth problem, and which is the most important one, is the cost and utilization. When we talk about the cloud, we basically tend to think that the cloud is something that is expensive, but that's not false. That's not a false statement. But if you think about the on-premise solutions, basically what you're doing is you are planning over capacity of 100%. But if your needs change to 50%, because you have all that hardware wired and connected to electricity and paid for in advance, and you have all those teams that are managing it already in place, what you're doing basically is you are paying 100%. You do not pay 50%. While if you go, for example, on the cloud solution, if your workload changes or if usage of the platform changes, your price will adapt. Or so now you are not only using 50%, that you are only paying 50%. And that's what we call pay on demand. And that's what the solution here, which is pay as you go. And we have multiple solutions that would change from a provider to another provider. We're talking about spot instances, dedicated instances that allow you to have some savings in terms of price. So this is for the problems of the solutions that I hope I have explained basically what the difference between the two. But there are many unsolved problems with this setup or with the cloud, and those problems are also applicable on HPC, and namely on HPC, because we are talking basically on research data or data that is sensitive most of the time. And some of those problems are the data sovereignty and jurisdictions. When we're talking about the data that you put in cloud, it's data that you give basically to the cloud provider, and that cloud provider has access to your data. And if you take into consideration some acts like the Cloud Act that give the US government the authority to go to your data, and if need be, then you will have a sovereignty problem. And that's why I mentioned the top tier companies, which are basically American, and this act applies on them. The other problem with this is the vendor lock-in at every layer. So if you go, for example, with AWS, and you have your whole setup, as I said, described in a YAML file and deployed in this cloud provider, migrating from one cloud provider to another is not something that is easy, because the whole concept, or the technologies or the solutions that are offered by one vendor differ from another vendor, and you need basically to rethink the whole thing. So we are basically locked in with the vendor that you go for the first time. You have also the operation dependence on a foreign hyperscaler. And as I said, the three companies are foreign companies, even if they have their data centers locally, but they are still foreign companies. And this might pose some political or regional challenges if the data is that sensitive. And then we have the data gravity and egress. And this is something very specific to the cloud, because when you are on premise, you do not basically think about the data movement between your loads or your nodes or your infrastructure. But once you are in the cloud, the data that goes in the cloud and comes with the cloud is something that you pay for, and sometimes it gets expensive. And those are the things that make the cloud specific. So now, what should we go to the cloud or not? And the easy answer always is it depends. It depends on what. It depends for or your workload. So if your workload is static and you have everything predictable, and you can get the 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 hardware in time, then you can stay on premise. But for example, if you are in a phase of research and you're discovering the solutions, then it's better for you to go to the cloud, because any investment that you make, you may roll over from. So it's better for you to go with something that is ephemeral, and that something would go that you turn off easily. And if you can also go with the hybrid solution, meaning that you have nominal usage, and then if there's a burst, then you can go to the cloud to offload this peak, then you can also do it. And most importantly, if the regulations of the data that you are dealing with allows it, then you can do it. But if not, then you are basically limited politically with those solutions. As I said, the HPC on cloud is not something that you would do on the regional cloud providers. You should always go with the hyperscalers, which is always a challenge with the data privacy. I think I come to the end of my presentation. I hope I gave you a bigger picture of what I'm talking about, and I hope you understood a little bit what I'm talking about.
Yeah, that was really amazing. That was very clear. Thank you so much. We're gonna start taking questions, so just waiting for the audience to type in their questions. We have a couple of questions from Ahmed, who's already with us in the studio, but he sent them in a private chat, so I'm just gonna read them for you. So Ahmed is saying, I heard that recently Slurm developed a solution for cloud. How does this version solve problem number 3?
I do not know about that solution. So let me go to prompt 3, which is paying like a supercomputer. Do you have an idea what Slurm is?
Slurm is actually a scheduler. It's basically a scheduler for HPC clusters. Like when you have a job and then you want to send it to, or like run it on the cluster, you run it through Slurm, and then you don't really get to know which node is running your job, but you just send it through Slurm. Slurm has access to all the nodes, and through Slurm scripts, you can just mention, for example, how many CPUs you need, how many GPUs you need, how much memory you need, how much time you need to allocate for your job. So Slurm is actually a scheduler resource manager, basically. So it stands for resource manager. But
Okay, and there's a. I'm not sure if they have their own data centers and their own cloud offering, or if they are using underneath the layer of orchestration, they are using the other cloud providers. But I would assume it's the first case, which is they have the own cloud provided offer, which means that the other problems of sovereignty do not come into the scene. Yeah, I think this is an interesting idea, and basically the solution of problem 3, as you can see here, is this ability to offload anything that you have on premise and take it into a node. So if you have Slurm, I'm taking assumptions here. If you have Slurm connected to your on-premise solutions and the other cloud solutions, the idea of like offloading and taking the queue of the jobs that cannot be run or can be delayed on locally to the cloud, that may be interesting.
yeah, I guess Imad solution is going in that same direction that you actually explained. But I think that for Slurm, for example, you can add sometimes some add-ons to be able to include or like to expand the solution itself, because it's an open source, so you can really do whatever you want in the installation. And I think that recently they added an add-on that allows for seamless integration with AWS. For example, you can run Slurm managed clusters on AWS. So I don't really know a lot of details about this, but this is also something that I came across. But
yeah, that's great.
Yeah, in addition to what you said, this probably will be a good solution for the problem.
There's another question about the layers of security on the cloud.
Yeah, that's another question.
Yes, we have. I think for the security, we have many issues here. The first one is like the data transfer from your local on-premise to the cloud. So if I take the example of AWS, they offer solutions to physically give you or send you physical hardwares or physical I don't know to call them cars or trucks into your premises so that you can insert in your data and then take it to the to the to the to the data centers of the cloud provider and put it there so that you can avoid the transit of the data in the internet, and this will solve the problems of latency and security for you. But in addition to this, they also have uh, other solutions like having the possibility to have a VPN that would connect your local premises to the cloud premises, and this would ensure that your data is not transparent and that does not travel through the internet. And depending on your solution, the solution that you choose, it will solve one of the problems. And I think you're also referring for the other issue, which is the networking. So in AWS, for example, you have a lot of options that allow you to have private VPCs, and then inside the VPCs, you have security groups. So a lot of solutions that would allow you to isolate your data in a very private network that would allow you to not interact with other networks. But I think there's another issue, which is the hardware underlying the virtual EC2 or the virtual machine that you are using. And for this, I think some cloud providers give you the possibility to have a dedicated instance physically. So they have a dedicated physical instance. And what this means is if you have two VMs, in the first scenario, having two VMs for two clients. So if there is a breach or something, which is rare, but the fact that there is a possibility to access the one machine and have access to the other one, you eliminate it by having these physical dedicated solutions. And another option, but for big companies, it is what we call the managed solutions. So basically, what AWS or those big hyperscalers do is they ask you to create the data center, to create to provide the infrastructure, and what they do is basically they install this abstraction layer and this management layer on top of your hardware, and then with this you can manage your whole setup, and then you can have the HPC workloads, you can have regular workloads, and you can have everything within the same thing. Can we trust the encryption that they provide? This is a very good question. And lately I had a project with a client where so I'm going to take the example of Sturm. So basically you have a provider of a software, of a SaaS software, and then underneath it, there is, for example, AWS. And the thing is, we were asking ourselves, is it possible to encrypt the data that is provided with the SaaS software in the disks of the AWS? The thing is, even if, for example, you encrypt the data that is sent here in this layer and you put it in this VM, the problem is somebody, if they get access to this machine outside of SaaS, they can always have the possibility to get the encryption key and then revert the process of decryption. The last question is how the high availability is managed in the HPC as the HPC as a cloud solution. Yeah, I think the high availability is managed the same way. What would be the difference is your tolerance of the latency between the zones. So if we're talking about high availability, generally what they do is you have a region, and within the region you have 3 availability zones. This is like the standard thing with the cloud providers, and then we have from one region to another this, I mean, over high availability, if you want to call it that way. Between availability zones, the distance, the physical distance is always small, so we can expect to have very slow latency. But if you have two regions, then at this stage you will have to think about the maximum latency that would allow in terms of this connection. So if you have a cluster that is spanned on multiple availability zones, then this is great. It's something that you should do actually, namely for the storage. But if you have a cluster that is spanned between the two regions, it is a question that you need to address basically with the cloud provider to see if the cluster allows this latency between its nodes.
All right. Okay, I actually have a question. Maybe it's more for discussion. Maybe there's no right or wrong answer for it. So previously you talked about the capacity planning.
Mm-hmm.
And if I understood correctly, you tackled it from the point of view of the user, right? So as someone using the HPC cluster, I need to plan for whatever jobs I'm willing to run on the HPC cluster, right?
Yeah. So basically, the end purpose of a capacity planning is to say I want this much CPU, this much RAM, this much storage, that setup of network. This is like the question that I'm trying to answer. And in order for me to answer it, I need to know how I'm using my data and what is the model that I'm using, basically. So this is
Yeah. So from the point of view of someone who's willing to provide, for example, an HPC facility. So let's assume that I want to design and deploy a cluster from scratch. I have a rough estimate of the usage of my cluster. So let's say I know that many people would use it, and then that many jobs are gonna run. But then as the users start using my cluster, I then discovered that what I planned for was actually not enough. And then I have two options. I either expand my cluster, which means my hardware. I buy new servers, I add them to my cluster, and so on, or I go to the cloud. And this is like, it will be like a hybrid system that I will be managing as someone who is providing that HPC solution. Now, my question is it really easy from a point of view of a manager or like an admin to do the hybrid approach? And money-wise, am I going to be better off buying time on the cloud or actually buying servers and adding them to my cluster?
That's a great question. Yeah, that's a great question to ask. So basically, you're not talking about the capacity planning. You're talking about the scalability of your setup. So when you start getting much more workload than you have anticipated, you need to scale out or scale up your data, basically adding the nodes or adding more resources to the node. And this is actually a great question because the answer is it depends. And as Ahmed answered or asked in the previous question, there are many layers or many questions that you need to ask yourself. Do you want this workload now, or is it something that you're planning in the future? Your geographical presence. So, for example, if you're sending data from Africa to data centers in the US, then there's a bit of latency there. There's also, if you are going to build locally, how much electricity are you going to pay for your data? How sensitive your data is? Are you able actually to build a data center and maintain it, or to extend your data center and maintain it? And there's also another question is, are you doing it for research or business? Because if it's for research, then you can basically, I believe, you can correct me if I'm wrong here, but your budget is basically secured. But if you are in a business setup, you are always thinking about budget restrictions, about investing in something and then taking it off, etc. So if you are looking for this flexibility, and you have the flexibility of decision to take your data out, and your data is not that massive, you can transport it easily to the cloud provider, then you can go with the hybrid solution, which is your nominal usage is always there on premise, and whenever you have peaks, then you can spin up automatically instances that would solve those problems or make the calculation, etc.
Okay, yeah, and I think at the end of the day, it's a business decision, because then, yeah, what is my budget, as you said, what I'm willing to do, what are the preferences of my customers or my users? Even if I'm a business, then I'm expecting customers or clients, but then if I'm doing just research, then I'm just talking about end users.
Yeah, I mean, at the end of the day, is business and political also. So there are a lot of parameters that you need to take into consideration before going with one solution, and it is one of the questions that you always ask yourself: who gets to decide what we do? Is it
Mhm.
the stakeholders or is it the employee at the end of the day? So if and I can tell about like my experience. For example, if you go in big companies, the employees or the engineers or the developers, for example, they want to have AWS as the provider because they are all certified in AWS and they know
Yeah.
how to use it. But the stakeholder, they have other interests. They want to go with
Yeah,
Google, for example. So at the end of the day, they
exactly.
would go with Google, and then you need to to go with the consequences. So it's not that obvious to answer. It's not only a technical question, because if it's a technical question, you can say hybrid is the optimal. I'm going to send it.
Right.
Have a price that can go up and down and have fixed one here. So we're going to go with hybrid. But there are other parameters that you need to take into consideration if you go in and answering or giving like solving that problem.
Yeah. And this is exactly what I was going to say, because this hybrid solution remains better than maybe having a bigger data center, bigger cluster that is overly available, let's say, for my use. So
Yeah.
having this hybrid or this elastic solution means that I can try the cloud for some time and see if my load is constantly getting higher. Then I would invest in servers and then expand my cluster. If it's just per peak, as you said, or sometimes it's, it goes up and down seasonally or something, then maybe the cloud would be also
Yeah,
a good.
and there are some people or some users who take advantage of just, for example, the storage solutions. We did not talk about like the S3
Mm.
solutions that allow you to have queuing of your data, for example, that is accessible immediately. You store it in S3, and then if it's not accessible, if it's something that is archived, that you can put it on S3 Glacier or something. So instead of you like managing this locally, you can offload this to the cloud. And as you said, it's still a hybrid solution, because what you're doing basically is the thing that you need now. You can put investment
Yes.
in them locally, but something that is archived, you can just send it somewhere to stay there, and you can call in case of an audit or in case if you want to retrain your models later on. Yeah, and the hybrid solution is always the best, because you can always change the workload that you put on premise versus the one you put on the cloud, and it's up to you to say whether you want to go this way or that way.
Yeah. Okay, that makes perfect sense. Let's see if we have any comments. Yeah, if the audience have any questions, they can drop them in the chat. We have Tissam. She's saying thank you very much for the guest, Mr. Aziz, and for the presentation. It was very informative. Thank you very much, Morocco
Thank you very
HPC as
much,
well.
Sam.
Are there any other questions? Yeah, Ahmed is saying, I think it also depends on the type of usage, if it's mainly for research or industry.
Yeah,
This is exactly what you
that's what we're
mentioned.
saying. Yeah, if it's a
Yeah.
business, you use it your research, and this would imply the type of data you're dealing with, or the type of usage that you're gonna make of your data. So yeah, it makes perfectly sense to make that distinction between the two.
Mhm. Okay, perfect. Thank you very much, Aziz, for being with us today. This was a really interesting session, really, with a more interesting discussion, I would say.
Thank you very much for having
And
me. It was a pleasure talking with you.
yeah, the pleasure is ours. For our audience, so this webinar will still be on YouTube, so you can always go back and look at it. And if you have any questions, you can talk to Aziz on LinkedIn, I would say.
And you gotta watch my podcast. That's what's important.
And watch the E after work, right?
Yeah, I'm just kidding.
Okay.
Yeah, but thank
All
you very much
right.
for having me, and thank you, Maddie.
Thank you. Thank you very much for joining us. Thank you, Aziz, for being with us today. And yeah, see you in the next webinar.
Yeah, see you. Have a good one. Bye.
Bye.